This is the 5.2 mini lesson starting on page 264. In this lesson, you will apply what you learned about multiplying and dividing with integers to multiply and divide with rational numbers. So consider this multiplication sentence, -2.5 times 3 1/5. What is the rule for multiplying sign numbers? So I would say here that a negative times a positive, we know my answer is going to be negative. Now they're telling me to use the rule to calculate the product shown. Show your work. So I'm going to give myself a box to put my answer in. In this case, I know my answer is negative, so I'm going to put in my number. So now really I'm just multiplying these two fractions. So I know when I take 2.5 times 3 1/5, I need to go improper. So I get 5 halves times 16 fifths, and I can simplify. And I get 8 over 1, which is 8, and I need to put it back in my box so that I get the sign. So let's try two more examples. A negative times a negative, I know that answer is positive. So I'm going to leave this empty. I know I need to go to improper. 3 times 5 is 15, plus 1 is 16 thirds. 4 times 4 is 16, plus 1 is 17 fourths. I can simplify. 4 goes in here once, in here 4 times. When I multiply straight across, I get 68 thirds. 3 goes into 68. 22. There would be 2 left over out of the 3. Okay, I can do the same thing with decimals. A positive times a negative, I know is a negative. So now I just need to multiply 5.02, 3.1. 1 times 2 is 2, 1 times 0 is 0, 1 times 5, 5. Moving to the second number, I put a little placeholder down. 3 times 2 is 6, 3 times 0 is 0, 3 times 5 is 15. Add 2, 6, 5, 5, 1, and then 1, 2, 3 for my decimal. 1, 2, 3. Put it back so we don't miss the sign. Okay, so if we go to division, consider this division sentence. -3 1/3 divided by 2 1/2. What's the rule for dividing sign numbers? It's the same as multiplication. So a negative divided by positive equals a negative. Use the rule to calculate the quotient. I know this is going to be negative. I have to go improper. So 3 times 3 is 9 plus 1. I have 10 thirds divided by 2 times 2 is 4 plus 1, 5 halves. Now remember, I need to write this as an equivalent multiplication problem. So I'm going to keep the first fraction the same, and I need to use the reciprocal of the second fraction. I can simplify because now I have a multiplication problem. 5 goes in 5 once, 5 goes in 10 twice. Remember, I cannot simplify across the numerators. It always has to be a denominator and a numerator. So 2 times 2 is 4. 3 times 1 is 3. 3 goes into 4 once. There'd be 1 left over out of 3. Put it back in my solution box so I get the sign. I'm going to take 2 more. Negative divided by a negative is a positive. So 8 times 2 is 16, plus 1 is 17 eighths. Remember, it's still division. 4 times 4 is 16, plus 1, 17 fourths, because this is the exact same thing as this. Now I'm going to change it to an equivalent multiplication problem by using the reciprocal of the second fraction. I'm going to simplify. I get 1/2. Put it back in the box so I get the right sign. And one last time with division. Positive divided by a negative is a negative. Now I'm going to divide 4.03 divided by 3.1. Can't have a decimal out here, so if I move this over 1, I have to move it over 1 here and straight up. So remember, I'm going all the way back. Does 31 go into 4? I'm putting a 0 so I don't make a mistake where I'm putting my numbers. 31 into 40 goes once. 1 times 31 is 31. When I subtract, I get 9. Bring down the 3. 31 into 93, 3 times. 3 times 31, 93. I'm done. Put it back in the box so I get the proper sign.